Hey everyone, welcome back. Today we're taking a deep dive into AI, but not just the flashy stuff. We're gonna get into how these systems really perform,
hmm
and also where the investments are going or maybe aren't going. For today's deep dive, we're looking at a research paper. It's called Generative AI Text Summarization. Performance analysis prospects. I know, a little bit of a mouthful, but it's got a lot of interesting information that can really, I think, help us understand how some AI projects, you know, some thrive and some just completely fall flat. One of the most striking things this paper shows us is a graph. It's tracking venture capital investment across different sectors. And you know what? It's not all good news. Since about 2022, we've seen investments trending down in almost every area except for media and IT infrastructure. Think about it.
Agreed.
Education, healthcare, even robotics, they're all drying up.
Yeah, it's a real change from, all that investment we saw back in 2021. And I think what we're seeing now is that a lot of those projects may be failing. So why is that? Are they just not living up to the hype? Or is it maybe they're using the wrong tools?
Well, that is the big question, and this paper seems to suggest
Yeah.
that a lot of it comes down to which large language model or LLM they chose. It's like you wouldn't use a screwdriver to hammer a nail, all right? You got to have the right tool, and the same goes for AI. If you pick the wrong LLM, the system won't work as well. You'll get bad results, and ultimately the project could fail.
That makes a lot of sense. So, okay, picking the right LLM is really important. But how do we know which one is the right one? Is there like an LLM for Dummies book out there?
Hmm. If only it were that simple.
Yeah.
But this is where I think this paper is really useful. It gives us a kind of a framework for how to evaluate different LLMs, particularly for text summarization.
Oh, text summarization. That's something I think we can all relate to. I mean, who has time to read everything these days? So, how did these AI summarizers actually work?
Okay, so let's say you've got this really big document you need to condense. The AI system will first, break it down into smaller parts like paragraphs. And then each paragraph, it's fed to the LLM along with, specific instructions called prompts. And these prompts tell the LLM what to do, what to focus on, what information it needs to pull out, and how to structure the summary.
So, it's like giving the AI a set of rules almost, like a recipe for a perfect summary.
Yeah, exactly. And it doesn't stop there. The AI actually analyzes what the LLM spits out, that initial summary, and then it sends it back to the LLM for even more refining. It's kind of like this back and forth conversation
Hmm.
where the AI is acting like an editor, guiding the LLM to produce something clear and concise.
Wow, that's really interesting. It's like having a personal assistant who can, sift through all this information and tell you the most important parts. But how do we know, if the LLM is actually doing a good job? How can we really measure its performance?
Right. Well, that's where we get into these three dimensions of LLM performance. The paper really dives into this,
Yeah.
and it's, I think, crucial for figuring out, how to pick the best LLM for what you need it to do.
Okay, so let's break those down. What are we actually looking for when we evaluate one of these LLMs?
So the first thing is what we call modelability for general tasks.
Hmm.
It's all about understanding if the LM can even do the kind of task you need. Can it summarize text well? Can it understand complex language and simplify it? Basically, can it read between the lines and really, get what's going on?
So it's like checking its basic skill set. Can it actually read and understand, at the level we need it to?
Exactly. And that's where these data sets come in to figure out how good an LLM is at these general tasks. Researchers use standardized data sets that test different skills. Like if you want to know how well an LLM can summarize factual information, you might use something called Trivia QA, which is full of trivia questions and
Wait.
answers.
So they're giving the LLM a pop quiz, basically, to see how well it can understand and summarize things.
That's a great way to put it. And by comparing how well the LLM does on all these different data sets, researchers can get a good idea of, its strengths and weaknesses for different tasks.
Okay, so I've got those general skills down. But what about how well the LLM performs on the specific job it's doing in an application? I mean, I guess a good reader isn't necessarily good at, I don't know, some summarizing legal documents, right?
You're exactly right. That's where the second dimension comes in, scenario-focused functionality. This is all about evaluating how well the LLM does in the context of the specific application.
So, like with our text summarization example, this is where we look at how good the summaries are and how fast the LLM can create them. Not just, can it summarize, but can it do it well and quickly?
Exactly. And to evaluate this, researchers will often set up these test cases that mimic, real-world situations. Like they might give the LLM a bunch of articles to summarize, and
Yeah.
then they'll compare those summaries to ones written by humans. They're looking for accuracy, clarity, conciseness, that kind of thing.
So it's almost like giving it a job interview, right? See how it performs under pressure and how it compares to, the human experts.
Yeah, great analogy. And this type of evaluation is super important for understanding how well, it'll actually do in the real world.
Gotcha. So we've covered general skills and how it performs on specific tasks, but what about the practical side of things? I mean, these LLMs sound pretty resource heavy, right? We're talking about these complex algorithms that have to crunch tons of data.
Yeah, that's a crucial point. And that's where the third dimension comes in. Hardware resource consumption. It's all about how much computing power, the LLM actually needs. How much CPU, RAM, disk space, does it eat up?
Yeah, because even if it's amazing, it's not very useful if it costs a fortune to run.
Exactly. And this is something that people often forget about, especially when they get excited about all these new AI capabilities.
Yeah.
But it's really important for real-world applications. If an LLM uses too many resources, it can make the whole application slow, it can be expensive to run, and in the end, unusable.
So it's like having a fancy sports car that gets terrible gas mileage. It might look cool, but it's not very practical for everyday use.
Exactly. So when we're evaluating an LLM, we have to look beyond just what it can do. We also have to look at how efficiently it uses resources. And that's where tools like, Telegraph, Influx, and Grafana come in to let researchers track how much computing power the LLM is using so they can spot any bottlenecks and, try to improve things.
So it's like having a fuel gauge for your LLM, basically. You can track how much it's using and make sure it's not draining your tank.
Exactly. By understanding how much an LLM consumes, developers can make smarter choices about whether it's the right one for their application, especially if they don't have a lot of computing power or, they're working with a tight budget.
Okay, so we've got these three key dimensions: general ability, specific task performance, and how much resources it uses. But how do we actually, measure these things? We can't just give them a letter grade, right?
Huh. I wish it were that simple.
Hmm.
It's definitely more nuanced than that. And that's actually what we're going to get into in the next part of our deep dive. We'll talk about the specific metrics and data sets researchers use and really get into the nitty-gritty of how they measure LLM performance. And we'll even uncover some of the unexpected challenges that they run into along the way.
Sounds interesting. I'm looking forward to unpacking all of that. We'll be right back after a quick break.
See you soon.
Welcome back, everyone. We've been talking about the three key dimensions for evaluating those large language models, or LLMs. And now I'm really excited to dig into how researchers actually measure their performance. You mentioned some interesting metrics, so let's get into that.
Yeah, it's a lot more complicated than just, measuring the length of something. Remember that first dimension, the model ability for general tasks.
Hmm.
Well, to really assess that, researchers use specific metrics,
Hmm.
and they use data sets that are specifically designed to test different language skills.
So it's kind of like having a toolbox full of different tools, right?
Yeah.
Each one is designed to measure a specific part of how well the AI understands language.
Yeah, exactly. One of the most important ones they use is called the GLUE score. It stands for General Language Understanding Evaluation. I know it's kind of a mouthful, but think of it as like a measure of how well the LLM uses logic and context to really understand the nuances of language.
Okay, so a high GLUE score means the LLM is pretty good at figuring out what a sentence means, based on the words around it, kind of like, a human would.
That's right. It shows that the LLM isn't just looking at individual words. It's actually, understanding the bigger picture.
That's pretty impressive. What other tools are in that toolbox?
Another really important one, especially for text summarization, is called ROUGE. It stands for Recall-Oriented Understudy for Gisting Evaluation. But don't worry too much about the long name. What it does is it compares the summaries generated by the LLM to summaries written by humans, and it gives a score based on how closely they match.
So it's basically checking how human-like the AI's summaries are, seeing if it can, get the main idea across in a way that we understand.
Exactly. Verge helps researchers figure out how accurate the summaries are and how concise they are and just the overall quality.
Okay, so GLUE for general language understanding, Rouge for summarization.
Yeah.
Are there any metrics that specifically look at how clear and readable the LLM's output is?
You're really thinking like a scientist here. Yes, there is, and it's called fluency, and it measures basically how well the LLM can express itself.
Fluency, yeah, that makes sense. But how do you actually measure something like that? Is it just about grammar?
Well, grammar is part of it, but fluency is more than that. It's about whether the text flows naturally, if the sentences are well structured, and if the writing style is, engaging and easy to read.
So it's like judging the writing style of, I don't know, a novelist. Some writers are just more interesting and easier to read than others, even if their grammar is perfect.
Exactly. And you know what's interesting? Fluency is often measured by actual human judges. They read the LLM's output, and they rate it based on how clear it is, how readable it is, and the overall flow.
So even with all these fancy algorithms, human judgment is still really important.
Absolutely.
Hmm.
Especially when it comes to these more subjective things, like fluency and style, human intuition and experience they're really valuable. AI evaluation is it's still a new field, and there's no one perfect metric that can capture everything about how we use language.
That's a good point. It's a reminder that AI isn't just about, cold, hard calculations. It's also about understanding how we humans, communicate with each other.
Yeah, well said. So let's move on to the second dimension, that scenario-focused functionality. Remember, this is about how well the LLM actually performs on the specific task it's designed for within a particular application.
Right, like how well our text summarization LLM actually summarizes those legal documents. How do researchers figure that out?
Well, it's a bit more a more targeted approach.
Yeah.
They'll often create these test cases that are like real-world scenarios, the kinds of things the LLM would actually encounter in that specific application. So, for example, they might feed the LLM a bunch of legal documents, and then they'd compare its summaries to summaries written by, actual legal experts. They'd be looking for accuracy, relevance, conciseness, all of that.
So it's like giving the LLM a work simulation, testing how it handles real-world tasks and comparing it to, the pro.
Exactly. And this often involves multiple human judges to try to, minimize any bias and make sure it's a fair evaluation. They might, for instance, each score the LLM summaries independently
Hmm.
based on, some predefined criteria, and then they average those scores to get a more objective assessment.
I see. So it's not just about did the LLM get the answer right.
Yeah.
It's also about how it got there, how it structured its output, and how it compares to, human expertise in that specific area.
Exactly. Evaluating scenario-focused functionality really requires a deep understanding of the task itself, and also the nuances of the application the LLM is being used in.
This is all starting to make a lot of sense, but I have to admit, this whole evaluation process sounds pretty complex and pretty resource intensive too. I mean, running all these tests, comparing everything involving human judges.
You've hit on a really key point there. Evaluating LLMs is a big challenge,
Hmm.
and researchers often run into, unexpected hurdles along the way.
Hmm.
One of the biggest challenges is just the sheer amount of data. Remember those data sets I mentioned,
Yeah.
like Trivia QA and all those?
Yeah, there's huge collections of text and data they use to, train and test the LLMs.
Right. Well, running all that data through multiple LLMs just to, gather those performance metrics, it can be incredibly computationally expensive. It requires a lot of processing power, a lot of storage, and it takes a lot of time.
So it's not just the LLMs themselves that are resource intensive. The whole evaluation process is also pretty demanding.
Exactly. And this can be a major roadblock for some researchers,
Hmm.
especially those who don't have access to, a lot of computing power or who have limited budgets.
Yeah, I can imagine. It's like trying to run a marathon while carrying, a heavy backpack.
Great analogy. And it highlights why we need more efficient evaluation methods. Researchers are always looking for new techniques that can give reliable results without needing, massive amounts of computing power. They're looking for ways to optimize the whole process, to make the analysis faster and more accessible to more people.
So it's not just about making the LLMs better. It's also about making the way we evaluate them better, too.
Exactly. It's about doing more with less,
Yeah.
getting those insightful results without having to rely on massive computing resources.
Okay, so data volume and computational demands, those are two big challenges. What other hurdles do researchers face when they're evaluating these LLMs?
Well, another interesting challenge comes from the fact that language itself is, subjective. Even with those well-defined metrics like RG and fluency, there's always going to be some level of subjectivity when you're evaluating something that's based on language. What one person thinks is a clear and concise summary, another person might not.
So it's like judging, I don't know, an art competition. beauty is in the eye of the beholder, right? And even expert judges might disagree on what makes a good summary or, a good writing style.
Exactly. And because of that, it can be really hard to say definitively, this LLM is better than that one,
Hmm.
just based on those numbers. Researchers have to be aware of that subjectivity and really take it into account when they're interpreting their results.
That makes sense. So even with all these metrics and data sets, human judgment is still really crucial when we're evaluating how well AI can handle language.
Absolutely. And that actually brings us to another fascinating challenge. The fact that these LLMs are constantly changing. They're constantly learning and evolving as they're exposed to more data. So the results you get today might be different tomorrow because the LLM might have learned something new in the meantime.
It's like trying to hit a moving target. The LLM is always changing, so it's hard to get a clear and consistent picture of how well it's performing.
Precisely. And this constant evolution means that evaluation has to be ongoing. It's not a one-time thing. Researchers need to keep monitoring LLM performance. They need to adapt their methods and, keep up with those ever-changing capabilities.
This whole conversation is really showing me how complex it is to work with these LLMs. It's not just about, plugging them in and letting them do their thing. There's a whole science behind evaluating them and making them better. And it's a field that's, constantly moving forward.
You've put it perfectly. Evaluating LLMs is definitely challenging, but it's also fascinating. And in the next part of our deep dive, we're going to look at some of the strategies researchers are using to optimize LLMs to make them more efficient, more effective, and more suitable for real-world applications.
Welcome back. We've been really diving deep into this world of evaluating large language models. We talked about those key dimensions, the ways they're measured, and even, some of the challenges that researchers are facing.
It's like we've been peeling back the layers of an onion, right? Uncovering all the complexity of assessing these AI systems.
Yeah, exactly. And speaking of uncovering layers, I'm really curious about those optimization strategies you mentioned. How are researchers actually making these LLMs more efficient and, more practical for real-world use?
Well, that's a great question. It's definitely a hot area of research right now. One of the really promising approaches is something called quantization. A bit technical, but basically it involves reducing the precision of the numbers that are used in the LLM's, calculations.
Okay, so instead of using these big, precise numbers, which I imagine take up a lot of, computing power, they use smaller, less precise ones. Does that does that affect the accuracy of the LLM?
It's surprising, but often it has very little impact. Researchers have found that they can often reduce the precision of those numbers without really sacrificing the LLM's ability to do its job.
Wow, that's fascinating. It's like finding a shortcut that doesn't actually, mess up the final result. What other techniques are they using?
Another interesting one is called pruning. Imagine you have this huge tree, right, with tons of branches and leaves. Pruning is basically, removing some of those branches and leaves, the ones that aren't really essential for the tree to grow and be healthy.
So they're like trimming the fat, making the tree more efficient.
Exactly. And it's the same idea with LLMs. Pruning involves removing unnecessary connections within the LLM's neural network, the connections that don't really contribute much to its overall performance.
So they're making the LLM smaller and more streamlined without losing any of its, core abilities.
Precisely. And just like with quantization, pruning can often be done without a big impact on accuracy.
This is really encouraging, it seems like. We're making real progress in making these LLMs faster, more efficient, and ultimately, more usable in the real world.
Yeah, it's definitely an exciting area, and there are a lot of other techniques that researchers are looking into. It's a very dynamic field with new approaches and innovations popping up all the time.
It makes me wonder, as these techniques get better, what kind of impact will they have on those investment trends we talked about earlier? Do you think this focus on efficiency and practicality could maybe, revive investment in some of those sectors that are lagging behind, like healthcare and education?
It's definitely possible. As LLMs become more efficient and less resource intensive, they become a lot more attractive for a wider range of applications,
Mm.
including, those sectors that might have been hesitant before because of the cost or complexity.
So it's like we're making AI more accessible, more
Yes.
affordable for industries that could really benefit from it.
Exactly. And that could lead to, a surge in investment and innovation,
Hmm.
and ultimately to the development of new AI-powered solutions that can tackle those real-world problems across all kinds of different sectors.
That's a really hopeful thought. It's exciting to think about how AI can be used to improve healthcare, education, and really, so many aspects of our lives.
It's definitely a powerful tool with the potential to make a real difference in the world.
Yeah.
But it's important to remember that AI is just a tool, right? And like any tool, it can be used for good or for bad.
That's a really crucial point. It reminds me of that saying, technology is neither good nor bad, nor is it neutral.
Exactly. It's how we use AI that really matters. And that's why this whole discussion about evaluating and optimizing LLMs is so important. It's not just about making these AI systems better. It's also about ensuring that they're used responsibly, ethically, and for the benefit of all of humanity.
I couldn't agree more. This has been a fantastic deep dive, and I feel like I've learned so much about the complexities of, working with and evaluating these LLMs. It's such a fascinating field, and it seems like we're just getting started.
It's been a pleasure exploring this with you, and I hope our listeners have gotten as much out of it as we have.
So, to wrap things up for everyone listening, as you navigate this rapidly changing world of AI, remember to choose the right LLM for the job. Think about not just what it can do, but also how much it consumes and how well it fits into your specific application. And most importantly, approach AI with a sense of responsibility and ethics and a commitment to using this powerful technology to make the world, a better place. Thanks for joining us on this deep dive. We'll see you next time for another exploration into the world of emerging tech.